All right, so this is our final lesson on graphing rationals, and in this lesson, we will be crossing asymptotes. So go ahead and start with a warm-up and answer those two questions there. All right, let's see how you did here. So on the first one here, we want to know how we can find out if the lines intersect and where. So remember, where they intersect is where they're going to have the same x and y value. So you can set them equal to each other and solve. And if you get an x value, then they intersect at that x value. To find the y value, plug the x value back in. All right, so we have 6, 8 is where those two lines intersect. Number 2, you should realize that before you even try that, attempt that, they're parallel lines. They're not going to intersect. But if we did set them equal to each other, the x's will cancel out. We have no x to solve for, right? So that's how we know when they're not going to intersect. Okay, so what we're going to do here is we are going to graph we could graph the whole thing without a calculator, but there's certain things that I want you to see with the calculator, and it's what this whole lesson is about. And that is that you can cross through horizontal and oblique asymptotes. You're never going to cross through a vertical asymptote, but we can cross through horizontal and oblique asymptotes. So what we want to figure out is when we cross through them, okay, and where. From all that we've known, asymptotes are guidelines that you never cross and you always get closer and closer and closer to. We're going to see in some circumstances that does happen where we cross them. Okay, so let's go ahead and start graphing this, and then we will at one point put it in our calculator to see what the rest of it looks like. Graph any holes, vertical asymptotes, horizontal or oblique asymptotes, and intercepts, then use your calculator to get the rest of it. We'll also do, oh yeah, I already put x-intercepts there and y-intercepts. Okay, so let's start with holes because that's always where we start. So we're going to start by factoring this completely and seeing if any common factor cancels out. So the numerator has a GCF of 2, so that's x squared minus 2. The denominator is factorable to x plus 4 times x minus 1. No common factors, therefore no holes. So no holes, none. Vertical asymptote, set the denominator equal to 0 and solve. We have x equals -4 and x equals 1. Horizontal or oblique asymptote, there's a horizontal asymptote because the degrees are the same. So we are going to take a ratio of the leading coefficients, which is y equals 2. Let's get some extra points here. Let's get x-intercepts and y-intercept. All right, x-intercepts, set your numerator equal to 0. The factored numerator is going to be easier to solve. So here's my factored numerator. I can set x squared minus 2 equal to 0 and solve. I get x equals plus or minus root 2. So I have two x-intercepts, positive root 2 comma 0 and negative root 2 comma 0. And my y-intercept, plug in 0 for x and see what you get for y. It's going to be easier to plug in the non-factored form. -4 divided by -4 is 1. All right, so here's the information that we do know that we can graph with. And then I'll also mention a few other things that are pretty important that make it easier for you to graph. So let's see what those are. All right, so we need vertical asymptotes at x equals 1 and -4. So I'm going to make my graph paper go up to 5, let's say. Hopefully that's enough tick marks. If not, I'll add more. 2, 3, 4, 5. Okay, so I need vertical asymptotes at -4. Remember, vertical asymptotes are always dashed lines. I'm just going to make them solid and then turn them into dashed lines in x equals 1. Move that over because that's definitely not going through 1. And then there's a horizontal asymptote at y equals 2. I don't have tick marks yet, so let's go ahead and do 1, 2. Put a horizontal line going through that tick mark, and then I'm just going to make these all dashed. Style. A little thicker so they're easier to see, and then this one too. Okay, oops, that's too thick. All right, so now I'm going to put arrows on the end to show that they go on forever and ever. Okay. All right, now there were no holes, but I'm going to graph the x-intercepts that I know. So I have an intercept at root 2 comma 0. So that's right root 2, which is a little bit more than 1, comma 0. And then negative root 2, comma 0. So like there-ish. And then I have a y-intercept of 0, 1 right there. Okay, so right away, these points make me feel like I'm doing something wrong. It's like, what? It seems like they're all underneath the horizontal asymptote, so what does this look like? Now, I could continue to plug in x values to get y values, okay? But there are also things that I realize right now, okay? So first off, I follow asymptotes, right? So I wouldn't want to follow my asymptote, or I want to connect these 2 points, but I'm not going to want to follow this asymptote here because then I cross through that asymptote right there. I don't want to follow it this way because I cross through the asymptote that way, so that's what it feels like, right? So I want to follow my asymptotes. So what I feel like my graph should look like, I'm going to do what I feel like it should look like, and then we'll say why it's wrong. So I feel like it should go like this and then come back down like this. The reason I know that that's wrong is because I don't have another x-intercept. There's no way that's happening, right? So the problem is I either have to cross through my horizontal asymptote or I did something wrong. All right, so let's get an idea of what this looks like here. So we're gonna pull it up on Desmos so you can see what's happening, okay? So here's what the graph looks like. If you look at that, remember we have a horizontal asymptote at y equals 2. We are passing through our horizontal asymptote. The piece on the right is definitely underneath y equals 2. It's gliding along that. It's definitely to the right of x equals 1. It's gliding along that. If you look at the piece to the far left, that is gliding along our vertical asymptote of x equals negative 4 and gliding along our horizontal asymptote of y equals 2. So those pieces are fine, but then we have this middle piece here, which does go down into the left, but then it goes up into the right and through that horizontal asymptote, okay? So now that I know that this can happen, we can figure out when we know it's gonna cross through a horizontal asymptote and where, okay? So it crosses through a horizontal asymptote. I'm gonna put HA for horizontal asymptote. Okay, so let's do a sketch of what it looks like. It looks like this, and then it comes back up here and looks like this. This piece was like this, and this, and then this piece was up here. I was like, I can't remember, but now I remember right there. Okay, so that's what the graph looked like, okay? And I wanna explain how I could have gotten that all without using the graphing calculator, because you're not going to be using the graphing calculator. So first off, remember what we did to see if two things intersect. We take the blue equation, and I want to know if it intersects the red asymptote. Okay, well, the horizontal asymptote. So in order to see if they intersect, I'm going to set the horizontal asymptote, which is 2, equal to my equation, which was 2x squared minus 4 over x squared plus 3x minus 4, and I'm going to solve that. Okay? All right, so in order to solve that, I'm going to multiply both sides by x squared plus 3x minus 4, and I get 2x squared plus 6x minus 8 is equal to 2x squared minus 4. And then I'm going to solve this equation. So notice it has a 2x squared on both sides. I'm just going to cross those out. I have 6x minus 8 equals 4, so I'm going to add 8 to both sides. I have 6x is equal to 4 divided by 6, and I have x is equal to 2/3. So I know that it crosses the asymptote at 2/3 comma the y value, which I already know the y value, it's 2, it's the horizontal asymptote. So at 2/3 comma 2, it crosses the horizontal asymptote, okay? So let's work backwards here. I knew those points, I knew those points, I knew this, that point, okay? So this is what I knew, and I now know that it crosses the horizontal asymptote at 2/3 comma 2. Once again, set the equation equal to the horizontal asymptote, okay? So now I can know what the rest of the graph looks like, right? So I know that this piece right here, oops, I erased stuff instead of drawing it. I know that this piece right here, I'm gonna follow up, cross through the asymptote, okay? And then I'm not gonna cross through the asymptote again, so this piece has to come down this way, okay? All right, so how about the other two pieces without a calculator? So this next piece right here, I already have this point, so I know it's gonna glide along these asymptotes, right? But what about that third piece? How do I know if it's here or here? From my calculator, I know it's up top, but how would I know? So what I'm gonna do is I'm gonna use the multiplicity of the factors that I got my vertical asymptotes from. So my vertical asymptotes came from here, and if you look, their multiplicity is 1 and 1, right? So that means when looking at the asymptote, that means that each of my pieces are gonna follow the asymptote in different directions. So what I mean by that is that if this was a square right here, that means that I'd follow the asymptote in the same direction as this other asymptote. But since it's an odd, since it's an odd multiplicity, it's gonna go in the opposite direction. So I have to follow the asymptote this way instead, and therefore I know that piece is right there, okay? So that's what I'm gonna use. Also, you could always plug in X values to get Y values to see where pieces are. That's absolutely fine. But I'm gonna try to always use that multiplicity. Also remember for zeros up in the numerator, if the multiplicity is even, you know it bounces at that 0 or crosses if it's odd. So you can use that too for help on other problems. All right, long explanation for one problem, but that's the whole entire lesson, okay? So here it says the graphs of rational functions can at times pass through horizontal and oblique asymptotes. However, it will never pass through a vertical asymptote. How can we determine if a rational passes through a horizontal or oblique asymptote? So once again, for both, actually, let's just write it for both ways. We are going to set the equation, so set the function equal to the asymptote. Okay, so you're gonna set the function equal to the asymptote. Now for an oblique asymptote, there's a little bit of a shortcut because you'll already have done polynomial long division. So if you set the if you set the function equal to the asymptote and solve, everything's gonna cancel out except for your remainder, right? So the shortcut to oblique asymptote is set the remainder equal to 0 and solve, because that's what'll end up happening. Remainder equal to 0 and solve, okay? And that is a shortcut, so if you forget it and you just notice that the function equal to the asymptote, you'll be fine. All right, so the rest of this is all practice. So let's go ahead and do that, okay? And I'll tell you at points to stop and try it and check with me, all right? Okay, so for the function, find the oblique asymptote. If you look, we have to use long division because we have a quadratic in the denominator. So we're gonna do 2x cubed plus 4x squared. There are no x's, so plus 0x minus 9 divided by x squared minus 3. All right, what do I have to multiply an x squared by to get a 2x cubed? And that is 2x. I'm gonna put that over my 0x and then distribute my 2x to x squared minus 3. So that is 2x cubed. And then negative 3 times 2x is negative 6x. I'm gonna write that underneath my 0x, subtract that off of that polynomial. I don't like subtraction, I'm gonna change it to addition and add the opposite. These are gone, I'm gonna make sure I drop this. So that's 4x squared plus 6x minus 9, and I'm gonna start over. So I'm asking myself, what do I multiply this by to get this? And that is 4. So this is a plus 4. Distribute, 4 times x squared is 4x squared. 4 times negative 3 is negative 12. Put that in parentheses and subtract. Looks like I'm running out of room here, so I'm gonna move this up a little bit. There we go. I'm gonna change it to add the opposite. These cancel. I'm gonna bring down that 6x. Negative 9 and 12 is positive 3. Okay, so that's my remainder. I know my oblique asymptote is y equals 2x plus 4. And then now I'm going to see if the graph intersects the asymptote. Once again, if I set this equal to this, everything after cross multiplying, or not cross multiplying, but after solving, everything's gonna cancel out except for this is equal to 0. So the shortcut is setting that equal to 0 and solving, okay? If it has an x in it, you could always solve it. So a way that we know that there is no intersection, that it doesn't cross through, is if I would just get a constant there. Okay, so we're gonna set 6x plus 3 equal to 0 and solve. We get 6x is equal to negative 3, so x is equal to negative 1/2. Now I need the y value, so I'm going to plug in negative 1/2 into my horizontal asymptote or the function. Horizontal asymptote is easier. Plus 4, and I get y equals negative 1 plus 2 is 3. So the horizontal, it crosses, so does it cross the asymptote? Yes. Where? At negative 1/2, 3. Okay, all right, so let's try some more where we're actually doing the graphing practice also. I think I have 2 here. Yeah, 2, and then the last is just find the horizontal asymptote and if it crosses where. Okay, so maybe you want to pause the video and try this yourself. At any point you get stuck, you can check in with me, okay? All right, so are there any holes in the graph? I'm going to factor this completely and see if there are any common factors. X minus 3 is not factorable, but the denominator is x times x plus 5. There are no holes in the graph because no common factors cancel from the numerator to denominator. Now any order from here. So I'm going to start back up the top. X-intercept, set the numerator equal to 0 and solve. Y-intercept, plug in 0 for x and see what you get for y. I get negative 3 over 0, which is undefined, so there's no y-intercept. Vertical asymptote, set the denominator equal to 0 and solve. I get 2 x values, x equals 0 and x equals negative 5. Horizontal or oblique asymptote, compare the degrees. The degree in the denominator is bigger. That means it's automatically a horizontal asymptote at y equals 0. Does the graph intersect the horizontal or oblique asymptote? Well, it's horizontal asymptote, and we find out by setting our horizontal asymptote equal to our equation. Our equation was x minus 3 over x squared plus 5x, right? X squared plus 5x, yes, okay. So if I solve that, multiply both sides by x squared plus 5x, and I get x minus 3 equals 0, x equals 3. So yes, it crosses the horizontal asymptote. The x value is 3. The y value is 0. So it crosses at 3, 0. All right, end behavior, I have to follow my horizontal asymptote. So as x approaches negative infinity, the function which was named f of x approaches 0. We're going to follow along with that. And then as x approaches positive infinity, our function will also approach, our y values will also approach 0. All right, let's graph this, okay? Oh, and I didn't even actually have to do the work for f now that I think about it, because if I said that there's an x-intercept at 3, 0, but there's a horizontal asymptote at y equals 0, I obviously am crossing through my horizontal asymptote because I have a point on my asymptote, right? But I was going too fast to realize that. All right, vertical asymptotes at x equals 0 and x equals negative 5. Remember, I'm making them solid right now, but I'm going to use my pen in a second to make them dashed. Y equals 0 is my horizontal asymptote. All right, I'm going to make them dashed. Okay, put arrows on the end to show that they go on forever and ever. All right, graph any and all points that you know. So no holes, x-intercept at 3, 0. So that's what I was talking about before. Like, obviously, I crossed through my asymptote. I have a point on it, right? No other information. So you might be saying to yourself, oh, I'm going to have to make so many tables of values. But if you know about vertical asymptotes and their multiplicity, and if it's even multiplicity, then you're approaching the same infinity. And if it's an odd multiplicity, you're approaching opposite infinities, then you don't, okay? All right, so I need to know if this looks like this or like this, though. That is the one thing I do need to know, or it would follow the asymptote, obviously. But I need to know which one it is, right? Because that'll help me out with the rest of this. So I'm going to plug in 2, right? That way I know if there's a point up here or down here, okay? And that way I know which way I'm approaching the vertical asymptote. Okay, so I'm gonna plug in 2. If I plug in 2, so I am gonna make a table of values here. X, Y, I'm gonna plug in 2, and I get -1 over. Plug in 2 in the denominator, I get 2 times 7, which is 14ths. So I get -1 14th. 2, -1 14th is like right here. So now I know that I have to approach this asymptote like so. And then I will approach this asymptote. I'll cross through it and still approach the asymptote, right? Not too shabby. All right, so now back to what I was saying before, okay? I need to know if this piece looks like this or like this. And I know it's one of those two because I don't cross through the asymptote again. I already figured out where I cross it. So I look at the asymptote of x equals 0. It came from this factor, which has an odd multiplicity. That means I'm not going in the same direction with towards my infinity. I'm going in opposite direction. So I have to be approaching this one this way. And I can't cross through the horizontal asymptote again, so it's got to look something like that. I'm not going to grade you on do you know where the min is or anything like that, but if you wanted to get points, you could, like accurate points. All right, and then the last piece, same idea. If you look at the asymptote of x equals -5, that comes from the factor of x plus 5, which also has an odd multiplicity. That means I'm not approaching the same infinity. So this is not going up, okay? It's going down like so, and that means it's gotta be this way, okay? Once again, you can make a table of values for everything and just plug in points and see what it looks like, but that's a waste of time to me. All right, here's another one which is already factored for us, which I am appreciative of. I see that there is a hole in the graph because there's a common factor of x plus 3. Set that equal to 0 and I get -3. Now I'm gonna write down what I have left and use that for the rest of my graphing. F of x equals 2 times x minus 1 quantity squared over x plus 6 times x minus 2. Okay. All right, so plug in -3 to see where the y value of the whole is. So -3 minus 1 is -4. -4 squared is 16. 16 times 2 is 32. I don't want to lose that in my mental math here. Plug in a -3 in the denominator. I get 3 times -5, which is -15. So I get -32 over 15, which is not simplifiable, so I'm just going to leave it. I could change it to -2 and 2/15, but I don't need to. All right, x-intercept, set the numerator equal to 0 and solve. So the only factor with an x in it is x minus 1. Set that equal to 0 and solve, I get 1, 0. Y-intercept, plug in 0 for x and see what you get for y. So plugging 0 in the numerator, I get 2. Plugging 0 in the denominator, I get -12. So that simplifies to -1/6. Vertical asymptote, set the denominator equal to 0 and solve. I get x equals -6 and x equals 2. Compare the degrees. This would be an x squared, and this would be an x squared also. So it is the same degree. So it's going to be a ratio of the leading coefficients. So it's y equals 2 over 1, which is 2. Does the graph intersect the horizontal asymptote? So we're going to set the horizontal asymptote equal to the function, which is 2 times x minus 1 squared over x plus 6 times x minus 2. All right, so I need to multiply both sides by this to get this to cancel out, but I want that to be a trinomial, so I'm going to change that to x squared plus 4x minus 12. And while I'm at it, I'm going to multiply this out because I'm going to need to, and that's x squared minus 2x plus 1. Okay, all right, so multiply 2 times the denominator. Multiply the denominator times 2, which is 2x squared plus 8x minus 24 is equal to. And then my new numerator is 2x squared minus 4x plus 2. The 2x squareds cancel. And then I'm going to add 4x to both sides and add 24 to both sides. So I get, and there's not a lot of room here, 12x is equal to 26. So there is a hole because there's an x remaining in the equation and I didn't point out. Divide by 12. I get x is equal to 13/6. So where it crosses, 13/6, comma, and then the y value, I'm just going to use this, y equals 2. So 13/6, comma 2 is where it crosses. I can do my end behavior right now because there's a horizontal asymptote. So as x approaches negative infinity, forgot what it was called, f of x approaches 2. As x approaches positive infinity, f of x approaches 2. All right, let's go ahead and graph this and do the last 4, which don't involve graphing, which is nice. Okay, vertical asymptotes, x equals -6 and x equals 2. Horizontal asymptote, y equals 2. Dashed lines. Arrows on the end to show that they go on forever and ever. All right, any holes in the graph? Yes, hole -3, -2, and 2/15. -3, -2, and 2/15. So right about there. Okay. All right, y-intercept 1, 0. Sorry, x-intercept 1, 0. Y-intercept 0, -1, 6. And that's all I got. Okay, well, this is enough information to graph, okay? I know that, oh, and I have also crossing through the asymptote. So where do I cross the asymptote? 13/6, which is 2 and 1/6, comma 2. So 2 and 1/6, comma 2, right there. Okay. All right, so I have enough information to graph this. So this middle piece I'm gonna start with. So I know that I'm not crossing through the asymptote again, right? So, and I can't cross through a vertical asymptote, so I gotta follow this one this way, connect those 2 points, and then I gotta follow this one this way. That's what that piece looks like. Oh, also, I just happened to, after I graphed it, I realized, see how I'm bouncing off the x-axis? This is also telling me that I'm bouncing off the x-axis because that is a repeated factor. It has an even multiplicity. I should say it has an even multiplicity, not the fact that it's a repeated factor. Okay, this other piece, right? So I have to decide if it goes like this or if it goes like this, right? So which one is it? So I'm going to use the multiplicity of my asymptotes factors. Both of the asymptote factors are 1, which means that I'm not going to have the same directional affinity. So this is not going this way. It's going the opposite way. All right, so I know that it goes like this. So it's got to cross through this, and then it's got to come back up and follow the asymptote. This one right here, once again, it's not going in the same direction. So it's going this way. And then this one's not crossing through the asymptote. Once again, if you want to make a table of values, you can. All right, last but certainly not least, we have these 4, which is much less work. So it says, for each function, find any horizontal or oblique asymptote and then determine if the graph crosses the asymptote. So this is just to like solidify that skill. So first off, if you look, you compare the degrees are the same. So it's a ratio of the leading coefficients. So this has a horizontal asymptote at y equals 2. Now I want to know if it crosses the asymptote at y equals 2. So I'm going to set my asymptote equal to my function. Solving this, I'm going to multiply both sides by 2x plus 1. And I get 2x plus 2 is equal to 2x minus 4. And when I go to solve that, subtract 2x from both sides, both of these cancel. I'm left with 2 equals -1, which is not true. And I don't have any x's left, so this does not cross the asymptote. Does not cross. Good? All right, moving on to B, same idea. Compare the degrees. The degree in the numerator is bigger, so that means that there is an oblique asymptote. So we're going to use long division to find it, seeing that there's a quadratic in the denominator. X cubed plus 0x squared plus 0x minus 1 divided by x squared minus 9. And then I ask myself, what do I multiply x squared by to get an x cubed? That's x. Distribute my x to my quadratic to the left. So x times x squared is x cubed. X times -9 is -9x. I'm going to subtract this off of that polynomial, add the opposite. This is gone. I have no x's, or sorry, no x squareds. So I have 9x minus 1, and that is my remainder, right? Because I can't say what do I multiply x squared by to get a 9x. So my asymptote is the line y equals x, or 1x plus 0. And then to see if it crosses, this has a remainder, I'm going to set equal to 0 and solve. Remember, that's my shortcut, because if I set this equal to x, I'm going to be left with this equals 0. Okay, so I'm going to do 9x minus 1 equals 0, which does have an x in it, and I can solve. I get x equals 1/9. So it does cross. So we're going to say crosses at 1/9, comma. So plug in 1/9 into either your asymptote or your original function. Always do the asymptote. It's easier math. You get 1/9.